Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.80. While solving this problem, we will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through this resistance and the value of resistance itself. Now move towards the problem. Exercise problem number 2.80. Find voltage VAB in given below figure. This is the circuit diagram of given problem. Inside this network, we have to find voltage between these 2 points labeled as VAB. So without wasting time, let's proceed towards the solution. In order to calculate voltage between these 2 points, we should have the value of voltage across these 2 resistances. And in order to calculate voltage across these resistances, we should have the values of currents through these resistances. So first of all, we will try to find out current through these branches so that we can calculate voltage across these 2 resistances. And whenever we succeed to calculate voltage across these resistances, we will be able to calculate voltage VAB by taking the difference of both voltage. For the calculation of current through these branches, we will use Ohm's law. 100 volt source is connected across both branches, so both branches will have same voltage appearing across their terminals. So in order to calculate current of this branch, we will divide total voltage with total resistance of this branch. Before moving towards the calculations, we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be known as I2. Value of I1 will be equal to 100 divided by the sum of both resistances because these resistances are connected in series connection. I1 will be equal to 100 divided by 120K. Value of I1 will be 0.83 milliampere. Similarly, I2 will be calculated by dividing 100 volt with 80 kilo ohm. Value of I2 will be 1.25 milliampere. We have calculated these branch currents. Now we can calculate voltage across these resistances. Voltage across this resistance will be equal to value of current through it and the value of resistance. Take the product of 0.83 milliampere and 100K. K will cancel out with milli and product of 100 and 0.83 will result 83 volt. Similarly, voltage across this 50 kilo ohm resistance will be the product of 1.25 milliampere and 50 kilo ohm. Voltage across 50 kilo ohm will be 62.5 volt. We have calculated voltage across these 2 resistances. Now we will modify this network by placing the values of voltage with their polarities inside this network so that we can apply Kirchoff's voltage law inside this semi-closed loop. First of all, modify the circuit by placing the values of voltage along with their polarities. Polarities of these voltage are taken according to passive sign convention theory. In this theory, the current entering terminal is taken with positive sign and current leaving terminals are taken with negative sign. Because the direction of current in both branches was downward, leaving from positive terminal and entering from negative terminal. That's why this polarity notation is taken. Now we will apply KVL inside this semi-closed loop to calculate value of voltage VAB. For that purpose, we will assume the direction of current counterclockwise. You may take clockwise as well. Start from this 83 volt, current entering terminal is positive, so 83 volt will be taken with positive sign. Move to next resistive element, current entering terminal is negative, so voltage across this 50 kilo ohm resistance will be taken with negative sign. Minus 62.5 volt. For this voltage VAB, current entering terminal is positive, so VAB will be taken with positive sign. Now subtract 62.5 volt from 83 volt. The answer will be 20.5 volt. Place this 20.5 volt on the other hand side of equal to calculate the value of VAB. That will result minus 20.5 volt. So the value of voltage between these 2 points inside this network is minus 20.5 volt. So this was exercise problem number 2.80. Thank you. See you again in next video.